Hello and welcome to our lesson on concentration. This is for higher students only. Concentration is a measure of how crowded a substance is. Look at the picture below. What's the difference between this really diluted substance here and the opposite, this really concentrated solution here? Well, it's the number of particles, in this case the Vimto particles, in this given volume of space. So if you notice, all these beakers have the same volume of liquid in them, but it's obvious that this one contains more juice particles than this one here. This is mostly water. So if we look at this diagram here, here's the concentrated solution, and you can see that there are many more particles of the substance, in our example the juice, in the volume of liquid, which is the water. In comparison, this one here is diluted, so you've got fewer juice particles or fewer particles in the same volume of liquid. There are two calculations you need to be aware of for concentration. They're very similar, but they are different. The first one here is in grams per decimeter cubed, and you do the mass of the solute divided by the volume of the solution. So how much or how many particles do I have, and how much space are they taking up? Here's the triangle. It's slightly different words, but it's the same idea. So mass of substance is the mass of the solute, and the volume of the liquid is the volume of the solution. It's worth recognising your volume of solution is in decimeters cubed. They're going to trip you up by putting it in centimeters cubed. So just be aware that if you want to convert decimeter cubed to centimeters cubed, you multiply by 1,000. And if you want to change it from centimeters cubed to decimeter cubed, you would divide by 1,000. Here's the other equation. Look, it's almost identical, but this time it's in moles per decimeter cubed. So the number of moles divided by the volume of solution. And again, here's the triangle, very similar, slightly different wording. Again, don't forget those conversions. Okay, so let's have a go at converting some of these units. So it says convert these volumes into decimeters cubed. So we've got centimeters to decimeters there and meters to decimeters. Have a go, pause the video and come back to me in a minute. So hopefully you've had a go. 250 centimeters cubed into decimeters cubed is 0.25. 125 centimeters cubed is 0.125 decimeters cubed. 1.5 meters is going to be 1500 decimeters. 50 centimeters is going to be 0.05 decimeters cubed, and 1000 centimeters cubed is going to be 1 decimeter. Okay, so let's have a look at a question. It says calculate the concentration of the following solutions. If you're confident, pause the video and have a go yourself, or follow along. So 10 grams of magnesium chloride in 1 decimeter cubed of solution. So I've left the two bits of information on the side there. I'm going to use that first one because it's in grams. I'm going to use this one here because it's in grams. There's my grams per decimeter cubed. And so I'm going to write out my formula because it says the word calculate. And if you see the word calculate, you need to write out your formula and do a calculation. Writing the formula also helps you to focus and make sure you don't lose your place. So it's well worth doing. Occasionally you actually get marks for it. Okay, so this is the equation. I need mass of solute divided by a volume of solution. Do I have a mass of the solute? Yes, 10. Do I have a volume of solution? Yes, 1. Okay, and that sum there is done, 10 grams per decimeters cubed. Nice and easy. Okay, pause the video and have a go yourself. Okay, so for this one here, again, I've got grams and centimeters cubed. That's going to be interesting. I'm going to have to convert that, aren't I? So I'm using this first equation again. Let's type that in. Okay, do I have the mass of the solute? Yes, 1.5 grams. Do I have a volume of solution in decimeters cubed? No. I have 150 centimeters, so I need to divide that by 1,000 to get it in decimeters. So that's going to be 0.15 decimeters cubed. And therefore the answer is going to be 10 grams per decimeter cubed. Okay, pause the video and have a go with this one. Okay, so this one here has got moles and centimeters cubed. Okay, so I'm going to be using this equation here then, aren't I? with the moles. So let's write that out. Number of moles divided by volume of solution. Okay, do I have number of moles? Yes, 0.690. Do I have volume of solution? Not in decimeter cubed, I don't. So 1,000 divided by 1,000, oh, that's easy, is 1 decimeters cubed, which gives me an answer of 0.690 moles per decimeter cubed. You can tell here, guys, why units are going to be so important, because grams per decimeter cubed would be incorrect. Moles per centimeter cubed would be incorrect. You need the moles per decimeter cubed for this one. So the way they're going to challenge you on the concentration is twofold. First of all, you've got the two equations which are very similar, and deciding which one you're going to use. And second of all, converting the grams per decimeter cubed into the moles per decimeter cubed. Now that's not part of that same equation. You need to use something else for this. And what you need to use is the relative formula mass. So if I want to convert from moles to decimeter cubed to grams per decimeter cubed, I would multiply whatever that number is by the relative formula mass of the substance. If I wanted to do the other way around, so I want to go from grams per decimeter cubed to moles per decimeter cubed, I would divide by the relative formula mass. Now, unfortunately, there's no way around this. You're just going to have to memorise that piece of information. But here is an example. So it says calculate the concentration of 0.1 mole per decimeter cubed sodium hydroxide solution in grams per decimeter cubed, and it gives you the molecular mass, or the formula mass, sorry, of sodium hydroxide there as 40. So I'm taking that 0.1 moles into grams, so it's going to be that first one there, and I'm multiplying it by the relative formula mass, which is 40, to give me 4 grams per decimeter cubed. Okay, pause the video and have a go at this question for me, please. Okay, so I'm going, it says calculate the concentration of 7.3 grams per decimeter cubed hydrochloric acid in moles per decimeter cubed. So I'm going from grams into moles, and I've got a formula mass there of 36.5, thank you very much. So I'm going to do 7.3 divided by the 36.5 to give me 0.2 moles per decimeter cubed. Okay, so let's look at this exam question. It's a multiple choice. So when I see this sort of question, I probably said this before, forgive me if you're hearing it again, I like to calculate the answer for myself. I don't look at A, B, C or D yet. I calculate the answer, I get myself an answer that I'm happy with, and then I compare it to A, B, C or D, and that way I'm checking that I'm happy that it makes sense first. I'm not confusing myself with all these options. So it asks me, so it says the solution of lead nitrate has a concentration of 66.2 grams per decimeter cubed. So I'm in grams. It gives me a relative formula mass. Lead nitrate is 331. What is the concentration in moles per decimeter cubed of this solution? So I'm going from grams to moles. So that is going to be this one here, isn't it? So I am dividing relative formula mass. So my equation is going to be 66.2 divided by the 331, giving me 0.2 moles per decimeter cubed. Once I've got my answer, I'm going to compare it to these. I've got 2 to minus 4. Hang on, if I move the decimal place, that's going to be wrong, isn't it? It's not. I've moved it too many decimal places. I've got 2 times 10 to the minus 2. So again, if I move that decimal place, I'm going the wrong way. No, it's going to be 0.02. That's too small. This one here, I am moving the decimal place. I think it's going to be C, isn't it? And obviously D is wrong because it's mentioned in 5. So I'm going to go for C as my correct answer there. You see what I was doing there? They've given it in standard form, and I'm just moving my decimal place there to give me the 0.2 moles, and the answer would be C.